Hello everyone. Welcome to the lecture on Dynamic Modeling, State Diagram Part 1. At the end of this session, the students will be able to draw a state diagram. In this video, I will be introducing the dynamic model concept, state and state transition, parts of a state, the OMT state notation. The dynamic model represents the time-dependent aspect of a system. It is concerned with the temporal changes in the state of the object in a system. Dynamic model actually gives the users a dynamic view with respect to the time, in comparison to the object model, which is static. The main concepts involved in dynamic modeling are the state, the transition, the events, action, and congruency of transitions. We will explore each one of them. So what is a state? A state is the situation at a particular condition during the lifetime of an object. To make it simple, each one of us in a lifetime goes through different states of the life, or you can say the phases. So basically, a state is a situation, a particular condition during the lifetime of an object. Consider the example, the newborn baby state, the childhood phase, the teenage phase, the adulthood, and the old age. In the same way, state is particularly a situation which is associated with a predefined or a fixed time for a particular object. Then, what is a transition? A transition is a change in the state. And how does this transition happen? This transition happens with the occurrence of an event that triggers the transition. For example, I talked about lifetime, the stages and the phases of life. So the moment you turn from 18 years of age, you are no longer a teenager. You are now into the adult phase. So after 18, you get the right to vote. So it's an event which makes the transition from one state to other. Now, we will understand the dynamic modeling actually with the diagram and what are the notations used for the state diagram. A state machine models the behavior of an object as it passes through number of states in the lifetime. So what is the actual purpose of dynamic modeling? The main purpose of dynamic modeling is to demonstrate, is to show the state machine model, that is the behavior of an object as it passes through a number of states in its lifetime. The state machine is graphically represented through a state transition diagram, and the state transition diagram consists of the state and the state transition. Now we will explore each of these notations. Now, before going to the notations, we will once again take in detail understanding about the state and how to identify the state. So, the state is an abstraction given by the values of the attributes that the object has at a particular period of time. It is a situation occurring for a finite time period in the lifetime of an object, in which it fulfills certain conditions, performs certain activities, or waits for certain events to occur. In a state transition diagram, a state is represented by rounded rectangle. So what is this trying to tell? It is trying to tell that it is a situation, it is a temporary interval, okay, wherein a particular object is there for a definite or a finite time depending on the system. Now, the state consists of so what are the parts of the state? So the parts of the states include the name of the state, the entry and exit actions, the internal transitions, and substates if any. So name, how do we write the name of a state? It's a string that differentiates one state from another. A state may not have any name also. It depends. But however, it's a good practice to have a name for a particular state. Then is the entry and exit action. It denotes the activities performed on entering and on exiting the state. Next is the internal transitions. Now there are n number of things that keep on happening, like the internal, when you switch on, okay, then there's a, consider the example of switching on the fan. So you switch on, you press the button, then the transition from the fan which is in the idle state, it starts moving. So idle to the rotating. And what was the entry and the exit action? So entry was it started rotating, okay, and then it started to move. The changes within the state that do not cause a change in the state, and this may be that sometimes which are not visible to the naked eyes. So therefore it may be the case that in a state diagram you have a state which is nested among other state. There are internal transition. So when we are developing a state diagram, it is important for the students to go through the actual behavioral description that is written or that is mentioned in the scenario and that is being drawn in the event trace diagram. Taking the reference from that, it can then move ahead by identifying the exact states for a given subsystem. Now, moving ahead, obviously for anything to with respect to time, there has to be a start and a final state. So therefore, the default starting state of an object is called as the initial state, and the final state indicates the completion of execution of the state machine. The initial and the final states are the pseudo states, that is, may not have the parts of a regular state except the name. So by default, initial and final state, they are not given a separate name. It is understood that this is the start and this is the final state. So the state transition diagram, the initial state is represented by a filled circle. The final state is represented by a filled black circle encircled within another unfilled black circle. This is also called as bull's eye. Now we will see the notations for drawing the diagram when we come to it. Before that, we will see the transition. So what is a transition? A transition denotes a change in the state of an object. If an object is in a certain state, when an event occurs, the object may perform certain activities subject to specified conditions and change the state. So what does this mean? That if an object is in a certain state, when an event occurs, the object may perform certain activities subject to specified conditions and that change the state. So in this case, a state transition is said to have occurred. Means, as I gave you the example of a rotating fan, as soon as the button was pressed, okay, the switch turned from off to on, which caused it to transit from the idle state to rotating state. Now, the transition basically gives the relation between the first state and the new state. Now, the transition is graphically represented by a solid directed arc from the source state to the destination state. Now, we see the OMT state notations for all the concepts that we have discussed previously. Now, the states are represented as nodes. As you can see over here, the initial state is shown by a filled circle and the final state is shown by two circles, one unfilled and the other filled. This is also called as the bull's eye. The next thing, the rounded rectangles are the ones which are representing the states, and here you have the state name written. Further, transitions are represented as edges between the nodes and labeled with an event name. As you can see, from one state to other state, it's the transition that makes it go from one state to other state. Therefore, the state have the transition's name written on it. Now, this is the standard diagram for the state dynamic model. Now, consider the example over here, which is a person is taking a taxi from place X to place Y. The states of a person may be waiting, that is waiting for taxi, riding, he has got a taxi and is traveling in it, and finally reached, that is he has reached the destination. The following figure depicts the state transition. So for the taxi he may be waiting, and then once he has got it, he may be sitting in it and riding. So this riding and waiting are two states, and the initial state and the final state are shown by the defined symbol, and the transition is over here. Now, I hope the students have understood the graphical notations for state diagram. Now the students are requested to pause the video for some time and identify the states and draw the state diagram for chess game where either black wins, white wins, and draw of the game. Pause the video for some time. This is the solution for the chess state diagram where we have white's turn, black's turn, and three possible conditions where either black wins, there is a draw, and the white wins. The transitions are labeled as black's moves, white moves, stalemate, checkmate, and finally either one of them wins. These are the references. Thank you for your patient listening.